Hello, welcome to another lesson of sectoral structures theory. Today we will talk about an important concept in sectoral structure theory, and it's going to be our entrance into the combinatoric aspect of this theory, which is really the essence of this framework. So we will talk about sectoral sets or sets of sectoral structures. We will define first the set STN as a capital N, ST subscript capital N, as the set of all sectoral structures. This is an infinite set that contains every sectoral structure. Again, this means every sectoral sequence which has a structural curve of length 2 pi. Remember, this 2 pi length is our main defining criterion. So not every sectoral sequence belongs in ST capital N. However, every sectoral structure belongs here. More importantly, we will define subsets within this infinite set. These are finite sets. We will call each of them ST subscript small letter n. So STN as a small n will be the set of all sectoral structures of degree n. So for example, if we say ST3, that means the set of all sectoral structures of degree 3. How many are they? Are they infinite? Are they finite? They are finite and there are very few. So first we have 3 subscript 3, which is this sectoral structure. Then we have this sectoral structure. We're going to read it, of course, from the L prime to the S prime end. We will say this is 2, 1 subscript 3. And finally, we have this xi type of structure, which is 1 raised to the 3 subscript 3. So we really only have 3 sectoral structures of degree 3. And therefore, this is the set ST3. The size of ST3 in this, of course, is 1, 2, 3. It is 3. It does not always equal to n, of course, so this is just the first few. So the size of ST3 is equal to 3. We will also use this chance to define one of our main functions that we will study throughout this book, which we will call the Meem function. Meem as in this Arabic letter, which we will use. It's a very pretty letter. It looks like a right angle with a little head. So Meem of noon is equal to the size of the sectoral set STN. So Meem of 3 is equal to 3. Let's go to another example, but before that, let's define ST1. ST1 is only one sectoral structure of degree 1, and it is really just an empty circle like that. And the size of this set is also 1. And then we have ST2, which is made of 2 sectoral structures. One is this theta structure made of 2 joined semicircles, and the other one is these 2 semicircles joined by a beta joint. So it includes only 1 theta structure and 1 xi structure. So we notice that Meem of 1 is 1, Meem of 2 is 2, Meem of 3 is 3. Let's see if this pattern holds. Let's look at ST4, the set of all sectoral structures of degree 4. We have our theta structure here, 4 subscript 4. And we're going to try to go in increasing order. So as the order of the sectoral structure or lambda increases. So this has an order of 1. Let's look at the order 2 structures. We have 3, 1, which is like that. It's just, it has this shape. So 3, 1, subscript 4. And then we have 2 squared subscript 2. So these are our second order structures. Let's go to the third order. We've got this really beautiful structure here, 1, 2, 1, subscript 4. And we've got 2, 1 squared, subscript 4. So these are our third order structures of degree 4. And finally, we have our xi structure of degree 4, which looks like this, and that's 1 raised to the power of 4 subscript 4. So let's write out our sectoral set ST4. This will be 4 subscript 4, 3, 1 subscript 4, 2 squared subscript 4, 1, 2, 1 subscript 4, 2, 1 squared subscript 4, and 1 raised to the power of 4 subscript 4. So the size of ST4 is 6. So Meem of 4 is equal to 6. So we see now clearly that Meem of n does not always equal to n. And we will study this function in great detail later on. So now we have defined our STn functions. We will also define another type of sectoral sets, which will be, instead of being based on the degree, will be based on the order. We will call these ST subscript star lambda. So star lambda, this indicates the set of all sectoral structures of order lambda. Now, ST star lambda, these are also subsets of ST capital N. However, each of these subsets is an infinite subset. So now we're seeing a very different way to divide STN. So each of them has a magnitude of infinity. For example, the set ST star 3 includes, we've seen this one, 1 cubed 3. It includes this one, 1, 2, 1, 4, 2, 1 squared 4. And then we're also going to have an infinite number of other sectoral structures of order 3 as well. Thank you.